The point of this video is to show how we can create a useful, reusable module. We will be creating a function that can generate combinations from given elements. This may prove useful in multiple places. We could generate a tournament matches or make advanced search in the string, just like the one in Visual Studio Code itself, or test edge cases, combining them in and out, as well as billion other use cases. A good candidate to isolate a functionality. By the way, we will see a lot of useful tools that we can use to make this more easy, like GitHub Copilot, JSDoc comments, and beyond tools, overloads, combinatorics, and in general, a design approach, something that I call a user principle. Let's invoke a command to show the status bar, and here we can see that Copilot is active. It will generate some useful code for us. Before we do that, let's first see how we can overload functions. There are two ways to do this. One is with function keyword and another is with constant arrow function. This example will demonstrate arrow function. Let's examine this interface. We want two approaches. One is to pass the numbers n over k and to make combinations choosing k elements from n elements. And this will start from 0, not from 1, so that we can use these generated elements as array indexes. And the other approach is to pass array of elements, and if this array is passed, then we will use the elements of this array. This is something that should be documented. JSDoc comes into scene. It can render markdown once you hover a symbol. After we have this in place, let's assign this to a variable and annotate the type. First signature should be improved with a generic type. Here we can see a kind of stuff that GitHub Copilot is really great for. It's a small unit of code and you don't have to reach for your discrete mathematics textbook to recover the formula or sit on paper and rediscover yourself. You simply type what you want and it draws from the common knowledge. And this is a good starting point for future optimizations if you desire to improve. After examination of the generated code, we see it is highly recursive, and this is not so optimal for performance. At least it could store previously computed combinations in a table. For now, let's keep it as it is and just document the functionality with a test. Here is a small test that shows that given code is working for both signatures. From here, in my honest opinion, there are only two options. Either you store this function or a mini package or a mini module as you like to see it in a monorepo and never ever write it again. Only case when you dedicate your time for this is to improve the performance, if this ever happens. The other option is to publish it and to simply download it whenever you need it. Just add a JSON package file and npm publish.